Okay, we have another system on the board. We are going to solve this very system, and we're asked to look for tension T1 in the diagram. Of course, if the system is in equilibrium. And it was JAMB question 1991, question 6. And we are still going to use the approach of the translational equilibrium in this case, whereby we consider the net force to be zero. And in this condition, we will consider it in two components, which has to do with the x component and the y component. Please take note, we are not looking at the case of torque, because the case of torque has to do with rotational equilibrium. For this case, we are not looking at it in that direction. We are looking at the case of translational equilibrium. Okay, solving this system on the board, I will have to still use that translational equilibrium approach to solve it. Under translational equilibrium, in static equilibrium, we have to consider the net force, that the sum of the net force to be zero, that is to say the net force must be zero. And in considering this net force, there are two things that will come to our mind, which has to do with the y component and the s component. Now, doing this one now, what can we really do? We are going to resolve the system into components. We are going to resolve the system into components, whereby I have to look at this one in this direction, this very one is T2 in this direction, and I also look at it in this direction. You can see that the T2 there is having an angle at the vertical. Look at it at the vertical, is having an angle 30 degrees. It means that I'm not supposed to have this angle at this position. But for the question, this is where they place the angle. Meaning I'm not supposed to have this very angle at this position. I'm supposed to have it here. Now to do that, you can see between here is 90. It means that for me to get this part, the remaining part here, since here is already 30 degrees, it means that I need to subtract this very one, I need to subtract this very one from 90 degrees. Therefore, the remaining part will be 60 degrees. It means at this point, I have 60 degrees. Okay, now please don't forget I already resolved this one into two directions, which is the y direction and the s direction. Okay, and this y direction has to do with the vertical direction, while this one has to do with the horizontal direction, which is the one of the s direction. Now, looking at this one, I mean that this T2 will have effect on this direction, will also have effect on this very direction here. Now, doing this, I will have T2, here is going to be T2, T2 as, okay, I'm going to have here T2 sine 60 degree. 60 degree, and this one will be T2 cos 60 degree. Please take note of that. Now, okay, now I have I have not completed the system. I need to also resolve this very one. Please don't forget that in this one here, there is a weight force, and that weight force is W, and it's mg. Please don't forget it's mg. Okay, now I have a complete system now, meaning I can now push forward. I can now push forward. Now, doing this, remember I told you that we have to look at the case of translational equilibrium. In translational equilibrium, remember I told you that the net force must be zero. The net force must be equal to zero. And in this one, we consider the two components. We consider the two components, the y component to be zero, and also the s component to also be zero. Please take note. The s component must also be zero. It means that the sum of the forces on the s component must be zero. The sum of the forces on the y component must also be zero. Okay, now let us now see what we will do now. Maybe we are going to use these two components to resolve the system. Now, looking at it now, which one is y component? The one that is vertical has to do with the y component. This one is vertical. This one is vertical. Okay, and this one is also vertical. Therefore, what will I do there? And what will I do there? Meaning I have to use this very one, taking this one, that is sigma Fy equal, and we have this one is positive, which T2 sine, this one will be T2 sine 60 degree, okay, minus W, because the W is the weight force and it's acting downward. Remember I told you, under translational equilibrium, the sum of the forces on the y direction must be zero. Please take note of that. Okay. Now, okay, we can move forward. Okay, apart from these two, there's no other forcing that, of course, vertical there. Meaning we only have two vertical forces. Okay, now we can now move and replace this very one. Here we now become T2 sine 60 degree, okay, minus mg. Okay, taking it over, I will have T2 sine 60 degree equal mg. Please take notes. Now, making T2 the subject of the formula, I will have mg all over sine 60 degree. Please take note of this, take note of this, take note of this. This is what I will now have here. This is what I'm going to have here. It means that in this case, I can substitute what is my m, the mass. Okay, the mass is 10. Okay, don't forget that we are using g. In this case, I'm going to take g equal 10 meter per second square. Please, I'm taking my g equal 10 meter per second square. Please, you're supposed to know that it was from this point we obtained this very one, which is 10 meter per second square from 9.8. Okay, from 9.8 meter per second square, we approximate and we have this. Okay, now I hope we understand that very aspect. It means that in this case now we'll be using this very one. I will use this very one will use it. Okay, in this case now we'll have 10. I'm going to have 10 here times 10 all over size 60. I'm going to be using salt form. I will use salt form to solve this very one. I'm going to look at it in decimal way. It means that sine 60 is simply root 3 over 2. Please take notes. Based on what we have in the option, it means that you can see the option is in a solved form, meaning I need to now use solved form to resolve this very one. Now, solving this very one, what can we do here? Let us see. It means that, okay, I can resolve the numerator and to be 100. Okay, 10 times 10, I'm going to have 100 there, 100. Okay, all over this very one, when I turn it over, therefore, I will have 100 times 2 over root 3. If I turn it over, please, I believe you know that. Okay, now what I'm going to have there, here is going to be 200 over root 3. Please take note. Here is going to be 200 over root 3. Now that one will be for the one of T2. Let me just bring it here. Let me bring it to this position. You that T2 here is 200 all over root 3 Newton. Okay. Okay, that one is set to there. Then, from the question, they said we should look for T1. From the question, we asked to look for T1. Meaning, for me to look for T1, what will I do? Since I have been able to resolve it to Y component, I will also consider the one of the X component. Meaning that I have to also look at the sum of the forces in the X direction. Now, to do that, I will say sigma, let me put it here, sigma fx equal, and what is the one that is horizontal there? We have this and this, therefore, we go on T, okay, we are going to have T2, and it's positive there, that one is positive, okay, cos 60 degree, okay, minus, this one is negative, minus T1, okay, minus T1. Now, here will be 0. Remember, under translational equilibrium, the sum of the forces in the x direction must be 0. Therefore, in this case, I have T2, and here will be, okay, here is going to be cos 60 degree minus T1. Please don't forget that. Okay, now doing this, I will have T1 equal T2 cos 60 degree. Now, in this case, what can I do? I'll have to clearly remove this part here, so that we can now resolve it. Okay, now, remember we already found our T2 from what we have here. Look at our T2. Mean that our T2 is 200. Here is 200, okay, over 3, and this very one is 0. 0. Okay, we are not looking at it in the case of decimal. We want to look at it without using decimal. Therefore, cos 60 degree will be 1 over 2. You mean that 2 here is going to be 1, 2 here will be 100. Therefore, my answer for T1 will be 100 over root 3. Over root 3 Newton. Over root 3 Newton. Okay? Let us see from the option. Let us see the best option here. It means that the one we have here is B. B is the right option. Therefore, we have B as the right option. This is all about this system we have on the board, this very system. This how to resolve it. Okay, we are going to consider another example. We want to consider another example, and after which we now move on to rotational equilibrium. And this one will now be on torque. We are now going to consider the case of torque. Okay, but we want to consider more example under this translational equilibrium. Okay, thank you very much for joining me on this platform. Please don't fail to like my page, the Jumbo Online Mathematics, and also subscribe to my YouTube channel, Mathematics Science Mega Tutorial. All the best.